packet we're getting?
I'll give you packets for the review tomorrow. I'll give you a packet for that.
Okay.
I try if there's a lot of diagrams to give you packets. So now, last class we were discussing limits from a graph. Now we're going to determine limits from an expression. All right, we're going to go over the different cases that we can have because each case has a different process that we would take. So, first scenario. If the limit as x approaches some number c of f of x, and this is when c is a number not plus or minus infinity. So when c is a real number. So whenever we have this, when we have the limit approaching some number, your first sort of place that you're going to, the first thing you're going to try is to plug into the number into the expression. So an example would be, well, part A, let's do this. We're going to try substitution first. So our example would be the limit as x approaches 4 of 2x plus 3. All right, so what I want you to do now is we're going to take this expression and we're going to substitute whatever they're telling us we're approaching. So substitute 4 into that. So now we'll do 2 times 4 plus 3. 2 times 4 is 8 plus 3 is 11. So the limit as x approaches 4 of 2x plus 3 is going to be 11. And I want to show you on Desmos once you're done copying this. You have it? Um, 2x plus 3. Okay, so we're saying, what were we approaching? 4? Okay, so as we're approaching 4, so here's 4, right here, right? Isn't that where our line is? So from the left, isn't it approaching this point? And from the right, isn't it approaching that point? What's that point? 11. So what's the limit as x approaches 4? The limit is 11. Isn't that cool how we figured that out algebraically?
So cool.
So cool.
Awesome sauce.
Guys, it's not nice.
Awesome sauce.
All right, let's talk about our next scenario. And this is still all when x is approaching a real number. So our next option is to simplify the expression. So let's say I have the limit as x approaches 5 of x squared minus 25 over 5. Oh, sorry, over x minus 5. Write it down, and then I want to chat about it for a second. So I told you your first instinct or your first option should be what? Direct substitution. Your first option should be direct substitution. So what you want to do here is, okay, well, it is approaching a real number. I'm going to directly substitute. When you directly substitute, you end up getting 25 minus 25 over 5 minus 5, which is 0 over 0. Do you agree? This isn't going to work for us. First of all, you can't have 0 in the denominator ever. That's just not allowed. So this tells us right off the bat, I cannot do direct substitution. Direct substitution is not working for me. So then, after you realize direct substitution is not working for you, then what you're going to do is simplify. So if we go to simplify, we're going to get an x plus 5 and x minus 5, right? Didn't I just factor that into a dots? And then on the bottom is an x minus 5. I can cross out the whole entirety of x minus 5s, which brings us down to what? X plus 5. Now that I'm down to x plus 5, guess what I'm going to tell you to do? Substitute in. Now you substitute in. So once we sub in, we're going to get 5 plus 5, which is 10. Can I go on to the third scenario? Okay, so now this is still case number 1 when x equals a number. So our third option is if all else fails, try to sketch or use logic. I'm going to show you. So if I tell you find the limit as x approaches -2 from the negative side of 5 over x plus 2. I want us to sketch an idea of what this is. You tell me, what is 5 over x plus 2? Something that we've sketched a lot of. The one with the asymptotes. Who remembers what that's called? Rectangular hyperbola. You got it. So we're going to sketch this. Don't worry about that 5 in the numerator. It really isn't going to affect us. So now it's usually x minus h on the bottom, right? So instead of going 2 to the right, where am I going 2 to the left? So there's an asymptote right here. And the other asymptote is at 0. And if you remember, doesn't the graph look something like this?
Yeah.
So now we have an idea of what the graph looks like, and I'm asking you to find the limit as x approaches -2 from which side?
Negative.
The left side, the negative side. So as x approaches -2, isn't that our asymptote? As x gets closer and closer to that asymptote, what's happening in the y direction? Down forever. What is down forever?
Infinity.
Negative infinity. What if I asked you keep going on this diagram. What is the limit as x approaches -2 from the positive direction? Good, Nico. Now we're coming at it from the positive direction. So we're going here, and what happens? We're going up forever. So that's positive infinity. So then if I ask you, what is the limit as x approaches -2 in general? Not Nico, somebody else tell me. Any ideas? Well, let's look at this. What's happening? So we always have to check from the left and the right, right? So from the left, it's going to negative infinity. From the right, it's going to positive infinity. Are they allowed to be different? They're not allowed to be different. So when they're not allowed to be different, what do we call that? What do we write? Because they're not allowed to be different. DNE does not exist. Limit does not exist. DNE. Right, this all falls under case number 1.
There's more cases.
There's more cases. This was just the first case.
Oh, okay.
The second case, well, do you guys want to try some of this case before I go on to the second case? Yeah.
Like 25 minutes.
There's only 2 cases.
As in like 2 more or like 1 more?
No, like 1 more case. There's only 2 cases altogether. You guys try these before we move on.
This was pretty light. It's not that bad. Kind of hyped this up too much, so I said it was going to go down.
Well, you should have seen how the A class was reacting to this stuff.
Well, the A class is the CP class.
I know. Oh, I'm recording. I'm just kidding.
That's crazy. Don't let them watch this.
I don't think they watch anything. Yeah, they don't subscribe and like. They're technically.
Lame. Those nerds.
Aw, that's love. I thought Nico was my 100th follower.
I was like her 98th.
Oh, really?
And I told her to do it because.
Thank you. All right, so we're doing that one.
Wait, no, you guys have to subscribe on your personal because once you guys graduate, it just goes away.
Sorry, I'm going to do another one. X squared plus 3 over x minus 1. There you go. Oh, I forgot to put the limit. Yeah. So you guys do these 2. Oh, and then I have to do one with you together.
Substitution would not work for the first one.
Substitution should work for the first one.
It's like weird though. It's like 0%.
Well, you're allowed to have 0 in the numerator. You're just not allowed to have 0 in the denominator. So anytime you have 0 divided by a number, what is it always? 0 divided by anything is 0. And 0 is an acceptable answer. You're just never allowed to have 0 in the denominator.
On the quiz, do you want us to write out fully, like
Nope.
limit, whatever, x?
No, you could just circle your answer.
Okay.
Does the x plus 1 always have to be under the limit, or can it be next to it?
The x arrow, you mean?
Yeah.
It's always under the limit. Can we go over this? So for the first one, I'm using direct substitution. So we're going to say 3 minus 3 over 3 plus 4. So we get 0 in the numerator. That is absolutely okay. You're allowed to have 0 in the numerator, just never in the denominator. 3 plus 4 is 7. 0 divided by anything is 0. So this limit is 0. For the next one, if you try direct substitution right away, what will happen? If you try direct substitution right away, what will happen? 0 in the denominator. Are we allowed to have that? No. So then we look at this and say, well, can I try to simplify this at all? Yeah. What can we do with the numerator? Yeah, we can factor it. X minus 3, x minus 1. And what happens with the x minus 1s? They cancel. So now I'm left with x minus 3. What do I do at this point? Now we directly substitute in. So we're going to have, what was it? 1. 1 minus 3, which is negative 2. All right, before we go on to our second case, I need to show you logic. Meaning we're not able to sketch it, we can't directly substitute, we can't simplify, meaning none of the other previous ones work. So I call it logic. So the limit as x approaches 0 of 1 over x squared. If I plug in 0, I get 0 in the denominator. We can't have that. I can't simplify because nothing will cancel. I don't know what this graph looks like because there's no parent function that I showed you that looks like this. So what we're going to do is we're going to sort of plug in numbers, and we're going to test from the negative side to see what happens and the positive side to see what happens. So we want to get closer and closer to 0, right? So we want to get closer to 0. If this is our number line, here's 0. We want to get closer to 0 from the negative side, and we want to get closer to 0 from the positive side. Do we agree on that? All right, so let's start off. I'm going to say when x is negative 3. What am I going to do? I'm going to take that negative 3 and I'm going to plug it into 1 over x squared. So this is 1 over negative 3 squared. What's negative 3 squared? So this is 1/9. All right, now we're getting closer to 0. So am I going to go negative 4? Am I going to go negative 2 now? Negative 2. We're trying to get closer to 0. So now I'm going to go negative 2. So now we're 1 over negative 2 squared, which is 1/4. All right, we're getting closer to 0. So now where am I going? Negative 1. So now I'm 1 over negative 1 squared, which is just 1. What does it look like it's doing, the y's? It looks like the y's are going up, right? You're 1/9, then 1/4, then 1. All right, I'm gonna change this, get even closer. Let's do negative 0.5. So now we have 1 over negative 0.5 squared. No. Nope. So this is, let's do a fraction. This is 1 divided by negative 1 over 2 squared, right? So this is going to be 1 divided by 1/4. Do we agree? Keep, change, flip. What is it? 4.
You lost me there. That was the stuff.
What are you confused about the keep, change, flip?
I'm not even there.
Wait, I don't know how to help you. No, this is still case 1. Nico, what's wrong? What got you? The 4?
Yeah, like the 0.5.
Like the algebra?
Yeah.
Okay. Let's use a fraction from the beginning. Negative 1/2. Okay.
That's better.
Instead of the 0.5. Sorry, I used a decimal. Shame on me. Okay. So what you're doing is you're going to do 1 over negative a half squared. Yes? Well, isn't this the same if we write this baby division sign 1 divided by negative a half squared like that? Nico?
Yeah.
What's negative a half squared? So that's negative a half times negative a half. Negative 1 times negative 1 is 1. 2 times 2 is 4. So it's 1/4. And now when we're dividing fractions, we keep the first one the same. Then we change the division to?
Multiplication.
And then what do we do? The 1/4, keep, change, flip. So then you're just left with 1 times 4, which is? 4. Now do you understand? Hooray. So what does it look like? What does it look like it's happening here? We're going from 1/9 to 1/4 to 1 to 4. This is growing exponentially.
Infinity.
Where is it going to? Infinity. So on the negative side, it is going up and up and up to infinity.
Would the next number be 9?
The next, so it depends on what you plugged in. So if you did 0.2, like 1/4, if you did 1/4, it's going to go to 16. But now we can't just do the negative side. We have to make sure the negative side and the positive side are what? Matching, that they're the same. Yes, Nico?
Would you necessarily have to do that step with the negative 1/2?
No.
I would just do the negative
So
one, like,
I just really wanted to show you how much it jumped up once we got to a fraction. But if you notice from here that it's growing exponentially, you would know that it's going. You don't have to show that fraction.
Got it.
All right, now we have to show the positive side is the same as the negative side. Are we ready? So now we're approaching 0 from the right side. So I'll do 3, positive 3. And what do we get for y when I do positive 3? 1/9. Then what am I going to do? 2. And what are we going to get? 1/4. What do we realize? It's the same. So where is it going to? Infinity. Since the negative side's infinity and the positive side's infinity, what is my limit approaching? Infinity. That's logic. All right, now let's go to case 2. I know. Your brains are growing. Okay. So for case number 2, there's only one scenario here. Case number 2 is when the limit of x approaches plus or minus infinity. So case number 2, approaching infinity. So this only works if you're approaching infinity. If you're approaching a real number, does this work? No. So we're only approaching plus or minus infinity. So what I want you to do when we're approaching plus or minus infinity is I want you to consider the most dominant power in the numerator and denominator. Cancel out, or I should say ignore all other terms. Whatever's remaining, ignore all other terms. Then simplify the dominant expressions if possible.
What do you mean dominant expression?
I'm going to explain to you. Are we ready? Maybe. Okay. So just jump into an example. The limit as x approaches positive infinity of 2x squared plus 3x plus 1 over x minus 1. I'll let you all write it down so then you could. Yeah.
Will the most dominant power be like 2x2 and x?
Yep, you got it. So when I say the most dominant power, I mean the biggest exponent, but you want to take the whole term with it. So do we all agree it's x squared on top? And on the bottom, what's the most dominant or the highest one? X. So you want to take their coefficients with it. So what that means is I'm going to take my most influential on top, which is 2x squared, over my most influential on the bottom, which is just x. You need the numbers in front of it. So you couldn't just do x squared and x. You needed the 2 with it. You need the coefficients with it. Then once we take, then what did I say? Ignore everything else, right? So now I said simplify if possible. Can we simplify this down? Yeah, when I simplify this down, I'm left with 2 times x, or 2x. At this point, what I want you to do is now sub in. So what am I subbing in this time? Infinity. So if I do 2 times infinity, is it still going to be infinity? Yes. So it is infinity. I'm going to show you. Can I show you the next one?
Yes. Is infinity like 0 or like any times by anything just infinity?
There's going to be scenarios where it's not going to be infinity. Let me show you. I'll jump to one now. So let's do this. The limit as x approaches infinity of 8x squared plus 2x plus 3 all over 4x squared minus 1. Now the thing with this is I can factor the bottom, but I don't care about that. I don't care that I can factor the bottom because what am I approaching? Not a number. What am I approaching? Infinity. So when we're approaching infinity, what's the rule? Take the most dominant. Take the most dominant. So I'm going to take the most dominant on top, which is 8x squared, and the most dominant on the bottom, 4x squared. What happens with the x squareds? They cancel. So now I am left with 8 over 4, which is 2. What is this telling us? The limit as x approaches infinity is 2, not infinity. Do you guys want me to show you on Desmos, or you don't really care? 2. Do we want to see it? Yeah, let's visualize it. I love it. Let's do it. Okay.
So if it was like a negative number and you substituted infinity into it, would it be like negative infinity?
So if it was like negative 3 times infinity would be a negative infinity. Yeah, you got it. I love that it's easy. You're making me so happy. Yeah, when I graph it, I use the original just to show you. X plus 3. Okay. Oh, no, that wasn't x minus 2. I'm like, this is wrong.
4x squared minus
4x. Did I do the numerator right?
Yes.
Okay. I was about to cry. I'm like, why isn't it working? Okay, so it's saying as x approaches, what was I approaching? Positive infinity?
Yep.
Do you see? It looks like there's an asymptote there. So as x approaches, it's getting closer and closer to 2. Isn't that so cool? Okay, let's keep going.
Okay, but let's solve it.
Yeah, but you're going to miss something. Wait.
Then I won't miss it.
Just after this problem, you could go. The limit as x approaches, doesn't really matter. Let's do negative infinity, of 2x plus 1 over x squared minus 9. Because we're approaching one of the infinities, we take the most dominant power. What are the most dominant powers here? 2x over x squared. Can I simplify this? Yes. So we're left with 2 over x. Now we sub in. If I'm dividing 2 by a negative infinity, isn't that an exponentially large negative number? Whenever you take a small number and you divide it by a crazy large number. Does anybody have a calculator?
Give you an error.
No. Okay, so do this. Do 2 divided by negative 1,000. Not even that big. What do you get?
Negative 0.002.
Okay, 0.002. What are we getting pretty close to?
0.
Getting close to 0. That's the thing. Anytime, let's put a star here. Anytime we divide a small number by an extremely large number, I'm going to put in parentheses plus or minus infinity, we will be approaching 0. So anytime we divide a small number by one of the infinities, it will always be approaching 0. Okay, one more. The limit as x approaches negative infinity of negative 3x squared over x. Oh, sorry, I forgot my other terms. 3x squared in the numerator, negative 3x squared plus 4x minus 1 over x minus 2. There we go. No equal sign there. So we're going to take our most dominant powers. So I'm going to have a negative 3x squared and then an x. Can we simplify this? Yes, we're going to simplify it down to a negative 3x. But what are we doing now? We're substituting in negative infinity. So what's a negative number times a negative number? Positive. So this is not going to be negative infinity. This is going to become positive infinity because a negative times a negative is a positive. All right, we're done for today. You do have homework.